let's first talk about Weep for Day. And when I was reading it, found so many examples of small details that showed the author did some really beautiful world building. For example, in the beginning, when Valizia and her family are on the train, she talks about how her mom is peeling indigos. And then a few paragraphs later, it's mentioned that the indigo is a citrus fruit. And to me, that's just so beautiful because like the indigo is like this planet's version of the orange, except it's purple because this entire society only exists in a part of the planet that doesn't get much direct sunlight. So it's always twilight. So I think that's a really beautiful example of world building. Did anyone see any others as they were going through Weep for Day?
I really loved all the naming conventions, After Day and Weep for Day, and the further you got away, it was all things to do with there being the sun and going into some place that was alien to them and lacked it.
Yes, absolutely. Naming is huge in building a fictional world, and I think that coming up with names for things can be really difficult, but one way to make it easier for yourself and more enjoyable for the audience is to tie the names of your places and your cities and your monuments and landmarks to the world building that you've done. Like what makes it different from our own world. Any other examples from the story?
I appreciated that when they were talking about the times to go to bed, they didn't call it night. They would call it respite because they didn't live in an area where it ever became night.
Yes. Yeah, that's awesome. I didn't even catch that. That's great. Any others?
I like the way that they just sort of described people's interpretation of the nightmares, and like they just did a really good job at describing the conflict and like this whole like war and stuff. I thought that was really well set up because it seemed like it was building, like we didn't really know what was going on until things got super deep, I guess.
Yeah. Any others?
I liked how the kind of culture and the religion and the kind of the belief system of the culture was kind of slowly revealed, and it mostly felt like kind of a background thing, but it was clearly well developed enough that it seemed real,
Yeah, especially in a short story, to have that kind of slow, progressive exposition instead of just one big information dump that can feel really clunky. I think that Weep for Day does that really well. I also noticed that a lot of the myths were pretty obvious. Myths about creation myths about how they came from the day side and like emerged from these hot lava pools, which ties into the religion and how the sun is sacred. And I think that was really beautiful. Do you have any thoughts about how astronomy was vital, or like how astronomy was integrated into this story?
At some point early on, you figure out what's going on with the world. And so my understanding of what was going on with the world was like I used an astronomical lens to understand that. So I imagined the planet, I guess like tidally locked with the sun or whatever, if that's the right term to use. Mm-hmm. And so, it was, I guess, just in a pure fantasy story, it might not, maybe it could have been written in a way where that wasn't so much, it wouldn't have been the first way that I would have tried to understand it maybe, but yeah.
It's interesting that you distinguish between this and a pure fantasy story. What does pure fantasy mean to you?
I think so. I mean, maybe it just had to do with the lens that I approached it with,
Okay.
but I guess what I was saying about how it might have, like, maybe it's possible for it to have been written in a different way, so that that wouldn't so much have been the lens that I used. And I don't know, like, then I would have called it more fantasy, but I don't know what that other way of writing it would have been.
Okay, interesting. They did talk a lot about technology, like the
Sure.
armored suits that they developed and the train system to go further or closer to night. So yeah, they did talk a lot about technology, and I maybe this is the sense that you got because they were doing that, but I got the sense that this is a civilization that survived because of science. They
Right.
could
Yeah.
have had the same setting, the same world, but instead of armored suits, people used magic to keep themselves warm. But because magic also has limits, and can evolve over time, they can't just go onto the other side of the planet right away.
Mm-hmm.
Okay. Anyone else thoughts on how astronomy was used in Weep for Day? Did you feel like you learned anything while you were reading it? Is that something you look for in your reading, to learn something, to take away new information?
I think I learned kind of the thing that I learned was, like, being comfortable in that way of thinking about a world. So, like, uh, it 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 drew me into a world where there were different rules, and so it, like, maybe, maybe there, I can't point to many new, like, facts about the world that I learned, but more like building a muscle of thinking about things in a certain way.
That's great. Did it do anything to the way you think about Earth?
It made me think about, like, okay, so one thing in the story was, like, I wasn't sure how believable it was that the humans in the story, like, would have evolved to require darkness to sleep,
Mm.
or, like, the fact that they seemed to, like, if they evolved in this place, then why would they need that? Like, they should just be able to, you know nap in the sun or whatever. um, and so that got me thinking about, like, I, uh, about sleep cycles in this world, and, like, also how we don't fully understand why we sleep at all, that kind of thing.
Mm. Yeah, chronobiology is a really interesting field,
Right.
and could have been used better in this story for sure.
Hmm.
Kiana, as the other astronomer in the group, did you have thoughts about Weep for Day and its use of astronomical themes?
Yeah, I thought it was really cool that they set it on a tidally locked system. I was confused as to whether this was supposed to be another planet, because they described the people as humans.
Hmm.
So it wasn't clear to me whether this was another planet that we've gone and, like, colonized, or if this was supposed to be Earth and Earth had somehow become tidally locked. And just the entire lore behind it. I mean, there was a lot going on, and I had some questions about it. But I mean, I think their use of astronomy, and it was clear that they had thought about it a lot, very carefully, and I thought that was really neat.
That's great. What were some of your questions?
Mostly about the humans, because when we started, I wasn't sure if these were humans or aliens and what they looked like, but then they were described as humans. So I just kind of imagined it was us. If they'd evolved on this planet and there was mention of dragons and things. So it was kind of unclear how much of this was science, how much of it was fantasy, if there was any magic involved, you know?
Mm-hmm. Yeah. That's a really good point that you brought up about, is this Earth in some distant future or in some like alternate or like parallel universe where it has the same shape, the same sun, the same moon, everything as Earth, but it just happens to be tidally locked. That's a very different setup than it being its own planet with its own evolutionary history and geographical history. That's a very different thing. So when you are building your own worlds and when you're creating stories to inhabit them, be sure to think about the fact that your most critical readers are going to ask these questions. If you don't want your planet to feel like Earth, then make that very clear. Talk about the fact that it orbits a different type of star or has multiple moons or whatever it is. And we will get into all of the different types of characteristics and features that you can manipulate in space to create different worlds. Cool. Any other thoughts on Weep for Day?
I guess just one thing is like, to your earlier question about what made me say it like wasn't pure fantasy. One of the things that did seem fantastical about it was just like the setup of having this very different seeming world that humans were on without without a scientific explanation of space travel or something like that.
Yeah.
And so I tend to just kind of assume I tend to not look for much of an explanation when that happens, because I'm just like, oh, that's a fantasy element, you know?
Right, we're also used to it.
Yeah, right.
All right. How did people feel that the world and the story worked together? Because I talked in the last class about how world building isn't just about creating a setting, it can also drive plot and character development. So did you see any of that in Weep for Day?
It's one of those things I would love to see explored more in a longer story. Like when at the end they're on a scientific expedition and they see, art and drawings and things the nightmares had, like they clearly had culture and just weren't just animals. And, you spend the whole time going, they have the solar church and they worship the day and the mention of dragons and stuff. And with the nightmares, the whole thing is, the terrible heat bringers and stuff like that, and how they're, they are people just very different and things they didn't understand. And, they had a mythology and a culture and all that. It was just based on that they grew up and lived in the night cycle of the world.
Mm-hmm. Yeah. Anyone else?
I think the fact that this is a tidally locked planet and that you have a day and perpetual night side, it helped drive this feeling like they were exploring to something really cold and dark and formidable. And I think that hammered in the fear that they must have felt as a civilization of this entire other side of the world. And I thought it worked really nicely together.
Mm-hmm. Mm-hmm.
Yeah, and I think the way that connected to just like fear, not only of just like some unknown, but of like the unknown life. And it's like, were these like humanoid things or what really were they? So it's like, in our world, it spins, so that doesn't give us a definitely like division because we all have day and night. But it's like, even on this other world, it's like that's the thing that drives people apart, which I think was a really interesting point to make.
Yeah, absolutely. Do you see any parallels to conflicts that exist here on Earth that people might feel that might be really familiar to people and that might make this story really relatable? Like, why do you think Das wrote it this way? Why do you think this was the world for this story?
I mean, I thought it was really interesting the way that it started off with the, like, I think the parents were like asking the kids, like, what does your dad do? And like you could see that there was this world, like I think getting it from the voice of a child too, where it's like they're literally being indoctrinated of like, this is how it is, and this is our understanding of it. Which yeah, I think that works really well with the world. It's like, you know, rigid, it's day or night, and it's good or bad. And it's like, obviously, this is what, you know, this is what good is, and we have to get rid of everything, you know, bad that scares us. And we're like not going to acknowledge our fear. And it's just about, you know, finding the good, which, I mean, yeah, any conflict in the world right now, it seems to relate to that. So.
Yeah, one thing I'd encourage you all to do as you read the stories going forward, because for all of the weeks, one of the assigned media is going to be like a creative story. So as you read those going forward, I'd encourage you to really think about what the writer was thinking when they created this world. Why did they choose to set this story in this specific world? How do they work together? How do they complement each other? Because for me, I think setting a story about conflicts between different groups of people on a tidally locked planet is really powerful, because it shows a stark divide between the two groups. It also gives you an opportunity to have two different, potentially like dominant species on a planet, which is rare, because it's rare for a planet to have two starkly different environments that can be held in such contrast with each other. So I think that was just like a really interesting decision, and I can imagine how that would be a thought process going through this author's mind when they were writing the story. Okay, so let's talk about the Kip Thorne interview. How many of you have seen Interstellar? Okay, I haven't, interestingly, but I think that Kip Thorne has a really interesting approach to science advising, and he has this book, The Science of Interstellar. If you wanted to dig deeper into how science and world building work together, then you can read that book. So that's why I picked this example. But after reading the interview, how important is 100% scientific accuracy in a creative work to you? I think that was grammatically right.
I don't think being 100% accurate is overly important. I think what matters is that you're working from a base where your world is consistent within itself. So, you know, starting from a scientific base is super helpful with that. But, you know, as long as throughout the story, the science you present to them is, you know, consistent within the world you're framing it as, because it is a work of fiction. I mean, it has time travel and wormholes. You know, as long as you can keep up the sense of disbelief and have plausible explanations, I think as long as that works with the story and makes the story compelling, that's more important than being, you know, 100% accurate.
Yeah.
Philip, I think for me,
James.
Oh, sorry.
Yeah.
For me, it matters so much about like somehow what expectations are set, which might happen in different ways. But like, for example, the film Gravity. I think like I watched that, and when I watched it, I think I kind of had the understanding that it was supposed to be really, you know, scientifically accurate or something.
Mm-hmm.
And then I read a bunch of critiques of the accuracies of things in the movie, and that really lessened my appreciation for it, because I had really high like that was part of why I was interested in the movie, you know.
Mm-hmm.
And that was, you know, at the same time, it was kind of a fun way to learn that science a little bit. learning about those deficiencies in the accuracy, I guess. But then with Interstellar, I think it's kind of like, I expect, because some of the science that it's dealing with is really like kind of, we don't know a lot about it, like he talks about it in the interview.
Mm-hmm.
It's like with the time travel stuff, I'm totally willing to accept like some kind of poetry in it all, where creative license, and so for me it's a lot about expectation.
Yeah, that's a great point. Do you have any examples of, because I think both of them could be taken for, someone could look at both Gravity and Interstellar and think that they're both realistic if they didn't have
Mm-hmm.
the familiarity with science that you have, because not everyone would know that things like time travel and wormholes are more speculative, even
Mm-hmm.
for scientists. So is there another example of something you've seen or read or played that was very inaccurate, but it was fine because no one could possibly believe it was?
Okay, so the first thing that comes to mind is the video game Outer Wilds, which is like, it's on some level a space exploration game, but the solar system that you explore is completely like cartoony and doesn't work like any real solar system would.
Mm-hmm.
But somehow it's done in a way that is like stylized in a way that just makes it fun, and still kind of like, you still feel like it's like Andy was saying, I guess earlier, about like internal consistency of the world. Like it has its own rules that make some sense, and so it still feels like a very sciencey game. And you're kind of playing an explorer who is like very much kind of a scientific explorer. So even though like there's all this strange stuff that there's no explanation for, like it would never be the real world.
Yeah, great. For me, it's Futurama and Galaxy Quest.
Mm-hmm.
Those are so fake. It's just pure entertainment. Does anyone else have strong feelings about how accurate a piece of fiction should be?
I don't mind some scientific inaccuracy. I think when you're working in fiction, it's best to stay within the realm of the unknown when you're trying to integrate science into it. But if, for instance, if they had gone with what the director wanted and broke like the speed of light, I think that would have been a pretty egregious flaunting of the laws of physics.
Mm-hmm.
I think so. There's like a line that you shouldn't really cross,
Interesting.
Unless, I mean, that's what you're going for. But if you're trying to be scientifically convincing, then you should keep in mind the actual science of things.
Okay. What's an example of something that that isn't a line for you, a scientific concept that you think can be either bent or broken for the sake of good storytelling?
Pretty much anything to do with black holes and wormholes is open game. Like we don't know anything anyway, right?
Okay, so as long as it is speculative and more theoretical, you think it's okay to play with?
Yeah.
Okay. Cool. Philip, how do you feel?
Yeah, I definitely agree with consistency. And I think that the way that it's presented speaks to the world building, and that's what could lead to feelings of inconsistency when you start off a movie and it seems like they're spending a lot of effort to show you how scientifically accurate it is, and they're like, yeah, we're showing you all this really cool stuff in the mission control room, and then the movie just goes off the wall, and it was like, wait, I thought this was real. That's the feeling that I had watching Interstellar. And I know I haven't read the book, so maybe there are things that were more reasonable that I just didn't think that they were. But yeah, that's what normally throws me off. Yeah, when it feels like there's a change from like, we're trying to keep this consistent with this world, especially when you think about the movie Gravity, that like, I think you have to get stuff like orbits right because there's nothing else in the movie showing us that orbits are like, so it's like, why would you do it wrong? Like you could work a little bit harder to make your story work without breaking that rule. So I think that's where that kind of stuff can get frustrating.
Got it. What do you think are some acceptable reasons to deviate from the science? And think broadly here, in terms of story, in terms of practicality, in terms of budget, especially if we're talking about visual media, there's often a budget associated. So what are some good reasons to not follow the science?
Maybe if the deviation from science is what's necessary to like bridge two parts of the story, to say like, oh, we're going to fast forward 100 years and everybody's going to be cryogenically frozen and then they're going to wait, or 500 years, and it's like somebody has to buy into that idea in order to move into this part of the story. And it's like, okay, great. But if I have to continuously break my understanding of how the world works in a way that wasn't made super clear to me, of this is the world that you're in now that you're watching this film or reading this book, then it can be a little harder because you're having to continue to convince yourself that, oh yeah, this is how it works. Does that make sense?
Yeah, that absolutely makes sense. I think that setting a number for yourself of, you called it like breaking your ideas of what the world is supposed to be. I've heard people call this like conceits, things that you will just concede to the world, just like believe that that's the case for the sake of following along with the story. Decide how many conceits you want. 1 is fine. 2 is okay if it's a longer story, but if you're asking your audience to concede like 10 different assumptions that they have about how worlds should work, that's probably pushing it and your audience is gonna get uncomfortable. Or put it down. You don't want either of those things.
I think it depends on, like, some stories require, like, we're on Tatooine and we have to communicate to the other side of the galaxy instantly. We're not going to explain how or why we can do that, but it's such a small thing that you really don't need to know.
Yeah. Yeah, keeping your audience focused. Don't waste time explaining something that isn't super important to the story. Otherwise, your audience will just get distracted and they'll lose focus. Any other reasons?
I mean, I just keep thinking of like Star Trek, which has like a million conceits that they, and it's somehow seems like it's part of the genre almost. Like, I don't know, like the show is kind of like a vehicle for these little self-contained stories, and they want to be able to use the same characters and have them in these different like episodes that are all very they just want to be able to write whatever story they want, and so they have all these conceits to support that.
Yeah, I love
that. And that seems okay to me. Like I like Star Trek, and it's I never, or at least I got over very quickly, like, oh, it isn't realistic that they can travel at warp speed or whatever,
Right. Yeah, I love that you brought up genre because that's such an important thing to think about if you're telling a story. And that doesn't mean that the lines between different genres can't be blurred. Some of my favorite stories are one that blur the lines between science fiction and fantasy, or urban and historical fiction. I love genre bending stories, but be aware of where your story falls on the like big chart of genres, because that tells you who your audience is, and you have to understand who your audience is if you're going to make a story that works for them. Something that's super relevant to this discussion is knowing who your audience is, so you know what their tolerance for conceit is. An audience that's used to watching things like Star Trek is going to be a lot more willing to have their view of the world broken over and over again than someone who watches like sappy Nicholas Sparks adaptation movies. Like those are very different genres. The audiences have very different expectations. Any other thoughts on Kip Thorne's interview? Did reading this interview change your understanding of Interstellar at all? Being able to see what was happening behind the scenes?
I thought the dynamic between Kip Thorne and Christopher Nolan and the other, I guess his Christopher Nolan's brother was Jonah. That was interesting, and it was like a little bit surprising. I guess I had an idea of the film as being, because I knew a little bit already of the story of this collaboration, but it was a little bit surprising that it took 2 weeks to convince Christopher Nolan to not do Faster Than Light, for example. I thought I had the idea that they were all on the same page more than that.
Yeah. I think one of the hardest things for creative people to do is move on from ideas that they had closer to the beginning of the creative process. And a common phrase that I've heard for this is you have to be comfortable killing your darlings. You have to be comfortable letting go of something that you've written. If it's an editing process, you have to let go of ideas you've had about how stuff should work for the sake of the story, which is really hard. I know that I have started so many stories and then reach some roadblock that I could easily overcome if I would just go back and change something that I decided before. But because I don't want to kill my darlings, those stories just stop. So one of the biggest pieces of advice for writing, I know I said that this wouldn't be a class about writing, but a big piece of advice I have for writers is to be able to kill your darlings and just let go of stuff and be expansive. All right. Any last thoughts on this media stuff before we get into the astronomy part of the lecture? Word. Okay, as I go through, Kiana, keep me honest. If I say anything wrong, flag me. But first, I'm going to start with some definitions. So a stellar system is a collection of planets, comets, asteroids, gas, dust. All of that is gravitationally bound to one or more stars. I don't remember who, but someone mentioned Tatooine earlier, which has 2 suns. It has 2 stars. Most stars in the galaxy, at least, I don't think we know for sure that this extends out to all of the other galaxies, but why not? Like, why would it? We're not special. Most stars exist in pairs or triplets or whatever. Very few stars are alone, and that is pretty much the only reason the sun is special. That's like that's the only reason, the only way in which we are not average. So that's what a stellar system is. And you can build your own stellar system from scratch, or you can take our own solar system and keep it the same or adapt it just a little bit. It's totally up to you and what your story requires. Here are some examples of stellar systems that some people might be familiar with. Hopefully we're all familiar with our own, our own solar system over here. The sun, the inner planets, the asteroid belt, the gas planets, Pluto, RIP, and then over here on the right is the TRAPPIST-1 system, which I think is probably the best known system of planets orbiting an M dwarf star. I will talk later about what M dwarf means, but it has 7 planets, 6 planets, no 7, I can count. Your pictures are just blocking the one. It has 7 planets. Most of them, about 4 of them, are in what we call the habitable zone, so the place where the temperature is just right for liquid water to exist, and it's a really compact system. So the entire TRAPPIST-1 system can fit within the orbit of Mercury, of our own solar system. It's very tiny. The fact that all of these planets are close together, if there's life on any one of these planets, means that it's much more likely for life to hop to other planets in the solar system, which just leads to a very different dynamic than we have in our own solar system, because as far as we know, we're the only life forms here. And because the planets are so far away from each other, it's hard to get from Earth to Mars, for example. So think about that and how the type of stellar system that you choose or create will really influence things further down the line. So they'll influence environment most directly. I mean, the type of sun, the type of star you have will really heavily influence your climate on your planet. So it influences environment, but it also influences culture in these other ways. Any questions about that? Cool. All right, so I'm going to talk about the different characteristics of a stellar system, but I'm going to do it in terms of dials that you can adjust or levers that you can press up and down. So for example, one of the dials is going to be the type of star that you orbit. And I'll say if your star is massive or very hot, these are the consequences. And if you turn the dial the other way so that the star is low mass and it's very cool, here are the consequences. So that's going to work. There are a lot of different dials that you can adjust because there are so many different ways that bodies out in space can be oriented towards each other. The type of star that you orbit is really important. I'm not going to just read this entire list because it's very long and it can feel overwhelming. You don't have to choose, like intentionally choose all of these different things. For the most part, you can say that all of this stuff, the planet's tilt, its orbital radius, whether or not it has a magnetic field, you can punt that decision and just say that it is exactly like Earth, except for one key difference. So maybe a planet is exactly like Earth, but it's 1.5 times the mass, for example. How would that change stuff? Or it's exactly like the Earth, but it's in a different part of the galaxy that doesn't that's surrounded by more dust, so they can't see as many stars in their night sky. So these are the things you can change. Any questions about this long list before I go on? Okay. So now I'm not going to go through quite one by one. I don't touch on everything on this list, and I combine some others. And so I'm now going to go through and tell you what happens if you adjust these dials in specific ways. But a lot of this stuff does actually tie into next week's lecture, which is going to be about geology and climate. So keep that in mind as we go through. Right, first, stellar type. There are a lot of different types of stars. Astronomers usually categorize them. I think there are 7. There are 7 different types of stars. Thanks, Kiana. And they all have the biggest difference between all of them. The way that we categorize stars is based on their mass. If an astronomer knows the mass of a star when it forms, then that astronomer can also really accurately predict when and how that star is going to die. And by die, I mean stop fusing hydrogen, stop burning hydrogen in the core of the star. So that's the definition of a star. It's a big cloud of gas that's collapsed in on itself and got so hot and so dense that it actually has enough energy to fuse hydrogen into helium. So more massive stars have shorter lives. Here, this is the most massive type of star, an O-type star, and they live for maybe 10, 50 million years. 50 million years is pushing it for the highest mass stars. And these O stars can be anywhere from, I want to say, 50 times the mass of our sun to 100 times the mass of our sun. I think we don't see stars much more massive than 100 times the mass of our sun. And then as you get towards an M dwarf star, which is the smallest, coolest stars, you can see here that they have an average temperature of maybe about 3000 Kelvin. An M-type star lives the longest. They live for trillions of years, and they live so long that we've never seen one of these stars die because the universe is only 14 billion years old. And so these stars continue to live for a really long time. The other thing you need to know is that more massive stars are hotter. They're more massive, so they can exert more of a gravitational force, which means that they can condense themselves further and get hotter in their course. And so an O-type star, even though it doesn't live for very long, it has a really extreme temperature of 50,000 Kelvin. And a good way to remember this is that stars, the high mass stars, live like rock stars. Like they live fast and die young and like burn bright.
That axis on the left says millions of years. Should that be different?
No, it's millions of years, where the O stars live for like negligible, like 10 million years. I guess.
Or what kind of star do we have?
We have an F-type star, or a G-type star-ish. It's like between F and G, but closer to G. So our sun will live for about 10 billion years. Oh, maybe this should be billion.
Okay.
Lifespan. Yeah, I will fix that later. Yeah, so that should be billion years, where our sun will live for 10 billion years, and it has a temperature of about 6,500 Kelvin. Yes. Any other questions about stellar type? Some other cool pieces of information you might want to have are that M-type stars are much more magnetically active than our sun. So they'll give off a lot of flares, which can come with heavy amounts of radiation and can affect electronics. When our sun gives off really big solar flares, that can often interfere with the power grid, depending on what part of the planet is underneath the part of the sun that emitted that flare. And so M stars can be really dangerous, but they live for a long time and they get less active as they age. O-type stars, we've never found a planet around an O-type star because they only live for about 10 million years, and that's about how long it takes planets to form. These stars just aren't the best environments for life. That doesn't mean it can't happen. If you have a particularly old O-type star, or if you have planets that form around an O-type star and then it turns into a black hole, that's like what happened in Interstellar, right? They had a planet around a black hole. So that is not impossible. It's just very dangerous to have. But maybe that's a choice you want to make. Okay. Cool. Now for planet size, mass, and composition, which is really important for the geology that we'll talk about next week, but I'll give you like a basic intro. So smaller planets are rocky. If you look at our solar system, the inner planets, Mercury, Venus, Earth, and Mars, are all rocky, and they are much smaller than the gaseous planets in our solar system. These planets are made of heavy elements like iron and nickel in their cores, but also a lot of other minerals, things like silica and carbon and all of the stuff that you can see in different forms, given the density and the pressure of the planet. I don't know if that made any sense, but heavy elements make up rocky planets. The bigger planets are gaseous. They're mostly made of hydrogen and helium. But when you get that big, you also have a lot of pressure. And so if you actually look at Jupiter, which is the most massive planet in our system, the outer atmosphere of Jupiter is pretty much entirely hydrogen, but it's so dense that at a certain point, it gets dense enough for liquid hydrogen to exist, or metallic hydrogen to exist. There are conditions that you can find in these gas giants that are so unlike any type of condition you can find here on Earth. We don't have metallic hydrogen occurring naturally here on Earth, but you can in such high pressure environments. Size and mass together give you density and surface gravity on a planet, and those have really interesting implications. If you have a planet with really high surface gravity, it's going to be harder for really tall mountain ranges to form, for volcanoes to form. It might be more difficult, like you're probably not going to find a redwood forest, for example, on a planet with really high surface gravity. Think about the different biology of the creatures you would find there. Birds might not be as common on a planet that has high surface gravity because it's harder to get off the ground. It's harder to fight the force of gravity. So think about that when you are creating the size and mass of your planet. And then here is a figure from a paper that gives you a sense of how the size and mass of a planet relate to each other. Most planets above 1.5 times the radius of Earth. So most planets that are bigger than 1.5 times the radius of Earth are gaseous planets. So you can, but it's probably unlikely to have a planet that's 3 times the size of Earth, so it's really big and is still rocky. So keep that in mind. Any questions about this plot and how to read it? So you have mass on the x-axis, and as you go across in mass, you can see that you also go up in radius. And as you go up in radius, then you also go up in mass. So these different, what do you call them, like vertical slices of this plot show you different types of planets. Here in this darkest blue, that's where you're finding worlds like the Earth. So if you want to create a world that's rocky like Earth, then try to keep the radius and the mass of the planet within these constraints along this line. Then we have Neptune-like worlds, Jupiter-like worlds. And this all the way on the right is where you start getting into territory where stuff looks more like stars than they do like planets. I think that is all I have to say about planet size and composition and stuff. We will get into a lot more of the composition side of rocky planets in the geology lecture next week. I don't have anything in here about creating, like building a world set on a gas planet. I've never seen one, but it's not impossible. I can imagine a gas planet that has things like giant manta rays floating around in the upper atmosphere. And I guess if you decide you want to set a world on a gas planet, my advice would be to draw inspiration from marine life here on Earth. Because these gas planets are so big and they have so much pressure that you essentially have an environment that seems very ocean-like, where density and pressure and temperature all change as you go to different levels of the atmosphere. So if you want to do something on a gas planet, then draw inspiration from the ocean here on Earth. Any questions about that? Or planet size and mass? Okay, cool. It's 2 o'clock, so before I move on, I want to give you a 5-minute break. Go get some water or do what you need to do, and we'll be back in 5. All right, let's bring it back. Cool. After planet mass, size, and composition, we get into how the planet is actually oriented towards its star. So its obliquity or tilt determines seasons on a planet. There are some very extreme examples where you have a very eccentric orbit, which actually, I think that I have a slide for that. But for most planets, the tilt determines how seasons happen over the course of a planet's year. That doesn't mean it's the only thing that affects seasons. If you have internal mechanisms like extreme volcanism, then there will probably be like an eruption season, and that will change your climate and change how climate varies over cyclical periods like a year. But for the most part, it's the tilt of a planet. And so you can have a planet that has no tilt, so as it orbits around its sun, it stays perfectly vertical. That means that different points along your planet, different latitudes, will have no seasonal shifts. They'll have day and night if the planet is also rotating, but it's not going to have winter, summer, spring, and fall. On the other side of that is a planet with an obliquity of 90 degrees. So that means its tilt, so the axis that the planet rotates around, is at one point of the year pointing directly at 2 points of the year. This axis is pointing directly at the star that the planet orbits. So imagine, I really need a cylinder. So my water bottle is the planet. It's a weird looking planet, but we're gonna go with it because it will have a very defined axis. So the planet is rotating like this about this axis, and the camera is the star. And as the planet goes around, oh, this isn't gonna work because at some point the water bottle is gonna move behind the camera. But you can see here that as the planet moves around the star, different points of the planet are going to be hit with a lot of direct sunlight. And that's what really determines seasons, the amount of direct sunlight that you have access to. And if that changes over the course of a year, then your seasons will also change. And the changes in direct sunlight are really extreme for a planet that has a tilt of 90 degrees. Moons can either stabilize or change a planet's tilt. Our Earth's axis is what we call precessing, so it's wobbling a little bit, almost like a top that is reaching the end of its spin, so it's going back and forth. This means that our tilt changes slightly over time, and that does have some effect on the amount of direct sunlight that different parts of the planet receive, but it's only a very small effect, so it doesn't do much to our seasons. If we had many more moons, then it would have a much bigger effect on our tilt changing over time. Any questions about that?
The whole idea of a tidally locked planet made me wonder if there'd ever be a reason why the tilt would be like always pointing towards or away from the sun, like if the tilt was locked in that way. Would that ever happen?
I can't think of anything that would make that happen.
Right. Okay.
The way tidally locking happens is that as the planet rotates, while it's also orbiting around the star, the two bodies will exchange like gravitational energy, and it's an energetically favorable state, basically meaning the system, the Earth, the planet star system doesn't have to do as much work if the planet is tidally locked. So if there's more energy in the system, then the planet can continue to rotate, but if not, then it's going to be tidally locked. And I don't think there's anything that gravitationally that would pull the like geographical North Pole towards the sun.
Got it. Okay.
Yeah. Next week, we get into the difference between geographical North Poles and magnetic North Poles, which is super cool, and has interesting consequences for the way people navigate, but that's next week. I feel like I keep just getting really excited for next week. Okay, planet rotation period, and this gets into tidal locking. So the faster a planet rotates, the more, is it oblate? Yeah, the more oblate it gets. So ideally, you would have a perfectly spherical planet, but if it's rotating really quickly, then centrifugal force, which is like a fictitious force, which makes is as something is spinning, centrifugal force makes stuff appear to move out towards the edge of the circle. So if you have a planet that is rotating really quickly, then the material will actually move towards the outer edge of the planet, and you get this bulge at the equator. And that can actually offset the planet's gravity. So our own Earth is rotating at about 1,000 miles per hour. If the planet were rotating at 17,000 miles per hour, then if you're standing at the equator of that very fast rotating planet, the centrifugal force would offset the force of gravity from the planet. So that's rotating really quickly. Like that's rotating fast enough that you might start pulling the planet itself apart, which isn't realistic. But know that because of a planet's rotation, your weight at the pole of a planet is different than your weight at the equator. So right now, the difference is about 1 pound between the north and south poles and the equator. You're about 1 pound lighter at the equator. So that's just something to keep in mind. Another thing to keep in mind for the very quickly rotating planet is that it's not just the material that will go towards the equator, like the rocks and stuff, the water in the planet will also go towards the equator. So if you have a very quickly rotating planet, it's possible that the entire equatorial region will be covered in water because the water will have left the poles and gone towards the equator. Some planets are tidally locked so that 1 day equals 1 year, meaning that as the planet is going around its star, one side is always facing. That's one of the reasons I chose weep for day. This creates a day side and a night side, which means that you have 2 sides of your planet with totally different climates, totally different environments for biological life forms to evolve. It just creates a really interesting environment. For example, our moon is tidally locked to us. You could definitely use that in a story, like maybe there is a group of people who live on the moon, but they live on the far side of the moon, and they don't know about us and we don't know about them until we develop the technology to actually launch stuff off of Earth's surface and orbit the moon, and we see their civilization on the other side. That would be crazy. Something like that. I thought I had more on this slide, but I did not. Any questions about rotation period and how that affects things? We were talking about chronobiology before. The rotation period also affects chronobiology. So if you have a shorter day, so your planet is rotating really quickly, so instead of 24 hours, every day-night cycle is only 18 hours. That also affects circadian rhythms. So it affects when people will sleep or if they'll sleep. It affects when they eat. That means it'll affect food culture. It'll affect how people interact. It can affect how people work, what typical jobs are. So keep that in mind. All right, I was right. There is a slide about eccentricity. So orbital radius, you might also have heard called the semi-major axis. And this determines the orbital period, or how long it takes the planet to go around its star once. This is essentially the length of that planet's year. Kepler's third law gives us a really beautiful and simple relation between the two. So the period squared, the period of the planet squared is proportional to this semi-major axis, which is usually shown as an A cubed. So as you move further away from your planet, it's pretty intuitive that the year also gets longer, but this is how the math works out. Think about how the orbital period, how long your year is, affects culture. If our year were longer, we would have longer harvest seasons technically, but we would also have longer winters. So we would have to harvest more food to carry us through that period where food is pretty scarce. There are also just like a lot of, think about how in your life you interact with a year, whether it's birthdays or anniversaries. Like how would it change relationship dynamics if you went longer between celebrating an anniversary? Because sometimes celebrating an anniversary can like bring spice back into a relationship, and if you go longer between those times, what does that do to relationships? How could you manipulate a culture so that people don't prioritize those big celebratory events? And so maybe it doesn't matter that they don't get to celebrate as many anniversaries, for example. Going back to tidally locked planets, think about how that would affect the life form's perception of time, perception of and like tracking of time. All right, so that's orbital radius. Great. A planet's eccentricity is how round its orbit is. Technically, this number goes between 0 and 1, where 0 is perfectly circular and 1 is so eccentric that the planet actually gets flung out of the system. And so eccentricity is important because it tells you what the temperature swing of a planet will be. Our planet, our own Earth, has a pretty circular orbit, and that's why it's the tilt of our axis that determines seasons. But if you had a really eccentric orbit, where at some points of the year, the planet's year, it's much, much closer to the star than it is at other times, then you have a really big temperature swing. And think about what it would do to biology, what it would do to culture, where if over the course of a year, your temperature swung by 50 degrees on average, this would be more extreme than the seasonal changes that we have because of our axial tilt, because of our obliquity. So keep that in mind. Any questions about eccentricity and orbital radius?
Do highly eccentric orbits tend to be also like asymmetrical like that more?
Asymmetrical, where like the sun isn't in the middle right here?
Yeah.
Yeah, always.
Okay.
Yeah, and so what happens actually is really cool. The closer you are to a star, the faster you move. So as this blue planet moves closer and closer to its star, it starts moving faster, so that this time spent closest to its star is actually really short, because it's just like whipping by there, and it spends most of its time out here because it's moving so slowly. So you have really extreme hot periods, but they don't last that long.
So you could probably, is there some like equation that I could find somewhere that would be like, you know, where for a stable orbit, like where would the sun end up being for a given semi-major axis or something?
Yeah.
Or a given eccentricity?
Absolutely. There are equations that tell you how fast a planet should be moving, depending on how far away it is from its star, and you can add eccentricity into those equations.
Right.
I don't have those right now, but I will send them.
That's fine. I just was curious if it was like something that's kind of, just predictable based on just those things, you know?
Yes, I will send that in an email after class. The other thing that you should know about orbital radius is that it also tells you what the average temperature of the planet should be. The closer you are to your star, the hotter you'll be. The further away you are, the colder you'll be. But those are just averages, and that has nothing to do with what the planet is actually made of, what its atmosphere is like, whether or not it has volcanism. So there are ways around that. Also, unless you want to get super into the weeds and the details about how everything works with math, you probably don't need these calculations. It's enough to just go qualitatively or conceptually and say, my planet is a little bit bigger than Earth, and its orbit is mostly circular, and it's pretty close to its star. So it's a hot planet. Like, you don't have to go into all of the math unless you want to write something like The Martian, where everything is super math and science heavy, and you want to give that type of experience to your audience. Because there are some people who really enjoy having like a scientifically constructed world, almost like it was made in a simulation. Some people like that. All right, and now think about where your planet is in the galaxy, because there are so many different parts of the Milky Way galaxy. There's this really chaotic region in the center. You can be somewhere within these spiral arms. Our sun is, do I have it here? I don't think I do. Our sun is about right here. Can you see my mouse? Yeah, so our sun is about right here. We are in what we call the disk of the galaxy. Think of the galaxy as a pancake, just like a really large pancake, and all of the stars are like blueberries in the pancake, and we're here. We aren't in one of the spiral arms, which is good because these spiral arms are dangerous. They're dense. They have a lot of stars where supernovae can go off, and you don't want to be near a supernova. It's one of my points here. So these are some things that you should consider. How many stars can your people see? There are parts of the galaxy that are a lot dustier than others. So if you are on a planet that's in one of those dusty spots, you probably won't be able to see many stars. Think about how that affects culture and scientific advancement. If you're on a planet where you can't see many stars, are you going to develop astronomy as a science the same way we've developed it here? If you can't see many stars, you're probably not going to prioritize space travel. So it's unlikely that people on planets like that will travel across the galaxy. Think about how close your world is to a star that can go supernova. I can tell you that in these spiral arms, there are a lot more stars, so it's more likely that you're near a potential supernova explosion. So that could be a really nice natural disaster to drive the plot of your story. To have scientists discover that a supernova is going to go off soon, how would people react to that? How would they try to protect themselves from the extreme amounts of radiation that the supernova would cause? And some of them are really bad. Like a really bad supernova explosion, if you're close enough to it, could just completely strip away your entire atmosphere. Or maybe the atmosphere stays, but all of the particles in your atmosphere get ionized, so they get changed and their characteristics change, and all of a sudden you just have a different type of atmosphere. That's some drama. That would definitely make people in a story do something. Think about close stellar encounters. This did not have to be in this slideshow, but this is what my last paper was about, so I wanted to include it. Because that's what scientists do. So close stellar encounters, not stellar collisions, because those are incredibly rare, even under the most extreme conditions, but just a star flying relatively close to another star. They are much more common in the center of the galaxy here, and close stellar encounters can be really bad for planets. It can rip planets away from their host stars. It can destabilize their orbits so that maybe not immediately after the encounter, but like a few million years later, the planet gets flung out of its system. Think about what it would mean to a culture if they observed a star flying really close by, and the scientists figured out that that star made the planet's orbit unstable. And so the scientists figure out that like they're fine, but hundreds of thousands of years from now, their climate's going to be totally different. Like what would they do to prevent that from affecting future generations? Would they even care? So think about that. If your world isn't set in the Milky Way, because it doesn't have to be, think about what other types of galaxies there are. Think about what galaxies can potentially do. Sometimes galaxies collide with each other. The Milky Way is going to collide with Andromeda in about 4-ish billion years, 5 billion years. The estimates are between like 5 and 10. So the Milky Way and Andromeda are going to collide. That's going to set off a huge explosion of star formation. So if you are on a planet in a galaxy that's colliding with another one, pretty much all of a sudden, like over the course of 100 years or so, your night sky is going to go from being dark to being as bright as day because of all the new star formation that's happening. So how would that change a society? Also think about what type of galaxy you're in. Elliptical galaxies are often older than spiral galaxies, which gives some cool opportunities. Older stars means that the people who live around those stars can grow older as civilizations, which means there's a higher chance for interstellar travel. That doesn't mean that interstellar travel can't happen in spiral galaxies, because there are those M-type stars who have been around since the galaxy first formed, like 13 billion years ago. So there are old stars in the Milky Way, but there are more old stars in the elliptical galaxies. So maybe you have competing factions of alien species that have proliferated across the galaxy, and that would create some cool conflict. So think about how different aspects of astronomy can drive conflict, can be used to motivate character development, can be used as just like a cool backdrop for a story that maybe you have a story in mind that has a certain theme. This is what we talked about last time. You have a story in mind that has a certain type of theme, and you need to tailor a world to your story. Think about whether or not there's an astronomical phenomenon that thematically aligns with your story. That's why I think having a tidally locked planet in Week for Day is so perfect, because it complements the story to have it set on a tidally locked world.